Hello, and welcome to the 10-buck test bench. I am the radio mechanic, and in our continuing series of repairing old equipment and bringing old test gear and bargain stuff back to life, we have on the bench today not only a fresh cup of coffee, but a General Electric clock radio, All-American 5 series string tube set, freshly arrived and overpriced from eBay, but since there are no yard sales or flea markets going on today, or lately they've been curtailed greatly, I bit the bullet and in order to make a video bought this set. Now this was purchased specifically to address a problem I see constantly on YouTube, where people buy these old radios or acquire these old radios and immediately plug them in to see if they work. And that was rather rude. The batteries went. I forgot to plug the power supply in. Okay, we're back. People immediately plug these sets in and they say, I just wanted to see if it worked, or it'll be worth more, I can sell it more if it works. Please, please, please don't plug these radios in. If it's coming from, someone's barn, someone's basement, it hasn't been plugged in 30 years, resist that urge to plug it in and just see if it works. You're doing more damage to the internals. And I understand the urge to plug these things in to see if they're going to work. Please resist the urge. You're doing more damage. You're destroying components. Even if it doesn't go up in smoke, there's a good chance that you're going to do more damage by turning them on. There's a few simple things you can do to make them relatively safe to turn on. And I know a lot of people use the dim bulb method with a Variac. That's great as far as it goes. But while you're waiting for the thing to warm up, that's not telling you that the plate bypass capacitor on the audio tube is shorted and you're driving all the current from the rectifier through the primary of the output transformer, because by the time it starts to smoke, it's too late. There are just simple things you can check before you turn these things on. And what I'm going to do with this video, the purpose I bought this radio was to take you through, hopefully step by step, in a way that makes it easy to understand what to look for and what should be checked and or removed before you turn these radios on. And I'm going to try to do it with an array of vintage test equipment. We've got a signal tracer here. We've got an old VOM. We have a VTVM hiding behind the radio. We have an old signal generator. We have some antique capacitor testers, and I've thrown in my Heathkit DC power supply. That'll become evident why I do that shortly, or during the video. But we're going to take you through and try to make this, try to show you how to make this radio safe to power up and test. Now, I bought this on eBay for way too much money. It's got a serious crack down this side of the case and along the back, and it's got a crack that runs all the way down here diagonal. Most of the plastics here, I think I can patch this together and it won't look half bad when I'm done, but that's going to be another video. I don't know if the clock works. I haven't done anything to this. I took it out of the package and it's sitting here on the bench just as I opened it out of the box. I can see, looking through the grill here, there's no grill cloth. Probably never was on this particular radio, but what worries me is I can see the speaker is one of those versions that doesn't have a piece of felt over the voice coil, which means it's probably full of dust and dirt. The voice coil is probably going to drag. And if these radios get exposed to moisture in a basement, very often the pole piece in the center of the voice coil corrodes, and that causes the voice coil to drag. So I don't hold much hope for the speaker in this. The clock may or may not work. Usually one of the things that retired these radios was the clocks gave up after 60 or 70 years. Can they be repaired? Sometimes yes, sometimes no. Usually it takes a donor motor, but we'll see what we get when we get in there. Thankfully, the tuning dial appears intact, although very warped from the heat of the tubes. You can see how it moves up and down. And trying to straighten that out would be a hopeless case. I don't know if they make reproductions of that or not. These radios aren't worth a lot. You spend anywhere from $20 to $50 to buy them. You put another $40 worth of parts and, you know, hours of labor into them, and what are they worth? $50 to $60 when you're done, unless it's something really rare. But it's a piece of history, and it's nice to have them working. Excuse me while I take a sip of my coffee here before it gets cold. It's unusual for me to have a second cup of coffee, but I've got a feeling this is going to be a long video. I may have to split it into two parts. Okay, I bought this on eBay. It was advertised as being a Model 60 General Electric clock radio. So while I was waiting for it to arrive, I searched around and I found the photo facts. Actually, in this case, it's a Ryder's, I think. Yeah, and found the schematic and the alignment information on it and studied it so I'd be prepared for the radio to show up. When it arrived, the first thing I noticed is it didn't have an external antenna connection on the back. And I said, gee, that's unusual, because the schematic shows clearly it's got a loop antenna and it also has an external antenna connection, you know, to pull in the weak signals. Then I turned the radio upside down, and it wasn't a Model 60 or 62, 60 being the mahogany, 62 being the ivory. It's a Model 500. The Model 500 is indistinguishable from the Model 60 from the look of it. It's got the same badge in the front, it's got the same dial, the same clock, everything's identical. Model 500 is mahogany, Model 501 is ivory. And a little more research, I found out there's a Model 503, 504, all the way up to Model 522. And they are all almost identical. There's some extra badging on the later models. The schematics are nearly identical. The difference is in the tube lineup. That is the main difference between them, is that some of them use the miniature tubes mixed with the octal tubes. Some of them are all miniature tubes. Over the years, as component availability changed, they kept the same schematic and just modified a few resistance and capacitance values to compensate for the difference in tubes. So essentially, this Model 500 is the same as the Model 60, but they eliminated that external antenna. So I am going to open this up and we'll get started. Now, again, I have not touched this since it arrived. The cord is stiff but not cracked, but it's quite dirty. Everything is quite dirty, and that's a good sign. And I don't know if you can see without me bringing the camera in closer, but there's large amounts of dirt inside of here and a lot of dirt on the inside, and it almost looks untouched. I'm hoping it's untouched. That gives me a much better chance of getting this going. So I'm going to remove the screws. I'm going to vacuum out some of the dirt, and we'll remove the screws from the bottom and get started. But I'll do that off camera. I removed the bottom screws, I noticed that as the washers came off, there was a very clear, clean imprint underneath here. The washers hadn't been put back on overlapping because of the play around the head of the screw. It would be possible, if it came apart, to put it on top and leave a little half moon of clean area. These look like they haven't been taken off of here in 40 years. Another good sign. That means nobody's been in here playing around, and hopefully they didn't plug it in. I'll continue here in a second. Okay, here's our first view, looking inside. An extremely clear outline and a very heavy layer of dirt. This radio hasn't been out of the cabinet in a long time. Good sign. Another good sign, all original components in here have not been touched. Nobody's been in here dicking around. We're going to have a very high probability of getting this radio going. The antenna coil looks solid. It hasn't fallen apart. There's no mouse damage. As expected, the speaker is absolutely filthy around the voice coil. I'll get this lamp up out of the way a little bit. And extremely crunchy. So the speaker will have to be replaced, no doubt. It's a 4 ohm speaker, which is unfortunate, but we'll find something to fit in there. If I turn the chassis up, you can see the layer of dirt that's in here. This thing's been tucked away somewhere and forgotten for many, many years. The wires going to the clock are soldered in place. There's no plug that I can find. So I'm going to have to pull the clock assembly out of the radio to make it easier to work on, and I can set the cabinet aside without worrying about breaking it any further. I will probably disconnect the clock and put a jumper across where these were connected, because this is the off-on switch for the radio. And just to make it easy to handle the chassis and move things around while I'm working on it, I think I'll just eliminate the clock entirely for now. In fact, if I disconnect these, I could plug in the clock and see if the clock works. In fact, if I leave the radio in the off position, no, I don't want to do that because there's a cross-the-line capacitor. Well, actually, with the switch off, yeah, I should be fine. We could see if the clock worked. I'll do that later. The tuning capacitor is not dragging. It's filthy, but it's not dragging or binding. Just lots and lots of years worth of dirt. Oh, the antenna has connectors, so I can remove the antenna. That's nice. I can slip those off. You have to be aware of which connection goes where. Sometimes it matters, the phasing of the antenna, whether you start with the inside winding or the outside winding. In fact, I'll bet the schematic even mentions that on this. If we... Well, let's look at the correct one. We'll look at the one for this model radio. And here it says green and yellow. And it says start, and I'm sure somewhere it'll probably tell us, if I look through alignment information. A lot of times it'll tell you the green wire goes to the center and the yellow wire goes to the outside. I'll find it later. We'll look. A lot of times you can have feedback problems, oscillation problems, if you get those wires reversed. Not always, but it can happen. But let me get this vacuumed out. Let me get rid of the dirt. Let me get these wires disconnected and get the clock, in the cabinet out of the way, and we'll continue on. Okay, we've cleaned up most of the dust and the dirt. I gave the cabinet a cursory wash to get all of the dust off of it. I took a chance with the label on the bottom, and it appears to have survived. I haven't been real thorough because that's going to need to be buffed and sanded after the cracks. Oops, after the cracks are repaired. This little tiny tripod doesn't move very smoothly, I'm afraid. The knobs cleaned up beautifully and appear to be their same ivory color they originally were. They just came out real nice. The clock face, which I thought had a huge scratch across the face, turned out to be dirt. That cleaned up nicely. I was very concerned about these corrosion spots on the bezel. I figured this was plated steel, and I think I was wrong. I think this is glass, and that means that's why that's scratch free. This screwdriver sticks to the back, but it doesn't stick to the front. So I think that is actual brass, which means I can polish that back up and give it a coat of clear lacquer, and that will be just as nice as the day it left the factory. And the General Electric badge on the front is also made of brass, so that should clean up nicely. Set that aside. After a good vacuuming and working the speaker cone in and out a few times, the speaker no longer rubs. Nice and quiet, although it does have to be glued back in. The surround here is come undone, but we can glue that back together without any problem. The chassis has cleaned up very nicely. Virtually, well, there's hardly any corrosion. There's a little bit of surface rust right here along the fold and the bend where they bent it, but everything else cleaned up nicely. You can clearly see the transition from the 30s and 40s to the 50s as we moved from optical tubes to miniature tubes. They didn't even change the tooling for the chassis. They have the same punch being used as would have been used for the octal sockets. You can see the diameter for the octal. They merely tooled up and made different miniature sockets to fit in the same octal tube. A little bit of deoxide on there. I cleaned up those contacts. So I would be willing to bet, even through the end of the model 500 range all the way up to 522, I bet you will find all miniature tubes still using this tooling on the chassis. I bet once they were tooled up for these sockets, they just went ahead and used them on the original chassis. Why go to the expense of retooling the chassis? And the photographs of all, and looking at all the schematics, they're all using the same shape chassis, so I bet they went along and used it right to the end. You can tell the 50C5 is the hottest running tube in there from the discoloration in the tube socket. I am eternally grateful that the speaker turned out to be okay, because not only is the output transformer mounted on it, it's not mounted directly to the chassis. It's mounted on this special standoff. Although I do see a screw poking through there. That might just be a separate piece. Oh, I guess that's not welded to it. Yes, there's a screw going through there. So I could have taken a standard 4-inch speaker and drilled and tapped a hole. So there you go. I was worried about nothing. It would be very simple to tap a hole in the frame of another 4-inch speaker and thread it and use the same spacer. So there you go. If you have one of these and it's got a bad speaker, that's a pretty simple fix. Just be careful where you locate the hole, and everything should go back together just like factory. Although the output transformer you may have to come up with a mount, but again, you could make a little tab to mount it on and drill and tap the top of the frame as well. There's no reason you couldn't do that. Just make sure that the speaker cone has a piece of felt on the front of it, and this looks like it may have had a piece of felt and it just rotted away. So we'll cut a piece of felt and put that over the front of the speaker to keep crap off of the voice coil. I don't know about you, but before we go any further, I simply have to know, now that this clock is cleaned up so nicely, is this still functional? The cord had to be cut off because it passed through this bracket which held it inside the radio, and to get it out I had to separate the cord from the clock. So I'm going to replace this anyway with one that has polarized prongs. For safety, it'll only go in one way, and as long as your house is wired correctly, it'll reduce the chance of shock. But I have to know, I just have to know, is this clock motor going to run? So I am going to tack solder this old cord back on, because this doesn't matter if it's polarized, and we'll see if the clock runs. I'll be right back. This has to be the original cord. I don't know how well this is going to show up on camera. Come on, focus, focus, focus. Can you see the green on the copper wire? I hope that's coming through on the camera. That's about 3.5 to 4 inches of cord where I cut this off, and it's corroded back 3 or 4 inches inside the insulation. So the insulation itself has been absorbing moisture, no doubt. It's hard to believe it wicked that distance, especially in a dry environment like the radio. So I'm thinking humidity has gotten through this. I don't even know if I'm going to be able to solder this. I may have to go downstairs and grab another cord. In fact, I'm not going to mess with this. I'm going to throw this away and go get a different cord. Okay, please excuse the glare. I have to know if this thing runs. I'm out of polarized cords. That's a heartbreaker. I'm going to have to place an order for some polarized cords. I've tack soldered just an old junk cord on here just to see if this thing runs. So let's see if I've got lucky. Oh, look at that. Look at that, look at that. It runs. Hallelujah. That means when this radio is all put back together, it'll make a nice... Well, I could put it in the kitchen. I could put it almost anywhere. I don't wake up to an alarm clock anymore. I'm retired. So, now that we know that works, I'll be able to sleep tonight. That was going to keep me awake. That means a little cleaning and a little lubrication, and with some luck, this clock will probably run for another 80 or 70 years, or however old this is. I'm going to guess this was probably late 40s when they started transitioning. I haven't found a date code in here, and there's no date on the schematic that I found. If I could find a date code, it was made in Ashland, Mass. by the Telecron Incorporated in Ashland, Mass. But I found no date code anywhere. So anyway, we'll set that aside and we'll get to work on the meat and potatoes of this whole thing. We were about to get into the dangers of turning on one of these old sets without making some checks, and we've run into a snag. Because this is not a Model 60, but a Model 500, there's a bit of a fly in the ointment. Now on the Model 60, this coupling capacitor from the detector and first audio into the grid of the power output tube to 50C5. On the other radio, on the Model 60, this was a .01 wax paper capacitor, which is guaranteed to be leaky. It is guaranteed to pass DC voltage. You've got 43 volts on the plate here. Some of that voltage will leak through this wax paper capacitor into the grid of the power output tube and start driving that into heavy conduction, which can make the tube gassy. You may have seen the anodes turn red on some old stereo systems, tube stereo systems, because either the bias was off or this capacitor was bad, which will throw the bias off. And it'll throw the tube into conduction and destroy the output tube. However, this being a radio dating into the 50s vintage, That has been replaced with a .005 capacitor, which is inside of this ceramic hybrid, which is something they started using in the 50s. You'll see them in a lot of old television sets. You'll see them in a lot of 50s tube radios, and ones, you know, the little plastic ones that sat on, you know, clock radios, very similar to this. But just about all of those tube sets using miniature tubes from the 50s had these hybrids inside them. And that is this component right here. This is what they're using to couple between the detector tube and the power output tube. And if we look at this, we can see there's several capacitors inside. We have a 002, 220 picofarad, 220 picofarad, and 005. And this 005 is the coupling capacitor for the 50 C5 audio output tube. What I've been doing lately, now you see people bring these things up on Variacs and, you know, bring them up slowly, and that's fine to a point. I mean, I used to do it myself all the time. The trouble is, a lot of these sets will have a bypass capacitor here. Now this one goes through a 150 ohm resistor to the B- bus. Some of these go directly to ground. If this capacitor is shorted, when you turn on the set while you're waiting for it to warm up, the rectifier begins to conduct. It begins pumping voltage through the output transformer, through this capacitor, shorted to ground, and while you think you're simply waiting for the set to warm up, what you're doing is cooking the primary of the audio transformer and overdriving the rectifier tube. You can damage one or the other or both. So this capacitor has to be checked for short circuits. If it's a little leaky, you can test the set, but you have to find out first of all, is it shorted? This capacitor, we cannot tolerate this one leaking. It's going to drive the tube into heavy conduction. So this capacitor, in most cases, if it's a waxy paper cap, has to go immediately before you put any power on the set. Just change it out. That's one capacitor you can just shotgun in. Another one to remove before you run any power through the set, you can just clip the leads on this one. Now this is across the AC line. This is just to eliminate any noise coming up the AC line. If Ma plugged in the vacuum cleaner in the same outlet or whatever, this is just noise bypass. This is going to be a paper cap almost every single time, and if these go, you're going to get a lot of smoke, and you know, it's going to explode basically. So just clip the lead on that. We can tolerate removing that. We'll replace it eventually with a proper X rated capacitor, across the line capacitor. You have X and Y rated capacitors. The X capacitors are for across the line, the Y capacitors are for the line to ground. In fact, that would be the case here. This 005 microfarad goes from the B- bus, which is directly connected to the line, to ground. If this one's shorted, you have a severe shock hazard because one half of the AC line is going to be directly connected to the metal chassis. And in some cases on these sets, they don't even have this capacitor and resistor. One side of the line is directly connected to the metal chassis. It's not uncommon in the early sets to find one side of the line is actually directly connected to the chassis with no isolation whatsoever. Later on, they started realizing that was a shock hazard, so they put a 470K, roughly half a meg ohm resistor, and this capacitor to bypass RF to ground. But they're paper capacitors, they fail. So we can clip this one also. We'll replace it because you can lead, it can lead to squealing and instability problems. But for testing the set, we can cut this one out. We can cut this one out. We also have to be wary of these 250 microfarad capacitors here, the filter caps. If those fail short circuit, you're going to destroy the 35W4 rectifier. Now, I don't know what they're getting for those today. In fact, I should fire up the computer and find out, but I won't do that right now. But dollar sign, I'm going to put $, question mark, and $, question mark here, and I'll look that up and put it in text down here somewhere, what I find the prices on those two tubes are. The Model 60 had a 50L6, which is basically the same tube as a 6L6, but with a 50 volt filament. And no, you can't interchange them because the current draw and voltage is completely different, and you'll either destroy the 6L6 or you'll blow up the 12 volt tubes because the 6L6 draws so much more current than these do. But as the 6L6s became more scarce, they changed over to the 50C5. Now the 50C5 supposedly has nearly identical specs to the 6L6/50L6, but according to the tube manual, the pin locations were relocated to meet UL standards. For whatever reason, I don't know what UL would have to do with moving the tube pin configuration around, but it says Underwriters Labs, to meet Underwriter Labs specifications, the 50C5 was developed, which relocated the pin locations. And again, I don't know why or what that has to do with UL listing. Somebody out there probably knows. So we need to first of all check for leakage here, make sure our filter capacitors are good, clip this across the line cap, and clip this one to ground. Now this one, do you have to do that? No, for safety you do, but I probably won't even bother with that right now because I'm going to be using an isolation transformer. We also have a 005 here across the B+. It's an RF bypass cap. It goes from the B- bus to the 90 volt bus. We should make sure that's not passing a lot of current because that could damage our tube also. So there's a lot of stuff we should look at before we plug this thing in. Now I'm going to cheat, or I'm going to use my new method, if you will, and I am going to hook up my Heathkit power supply and inject DC voltage here into the B-. This way the tubes won't be conducting, and I can go through and I can find out, first of all, are the filter caps shorted because I have current limiting on the supply, and I can find out, is my coupling cap leaking. And I'll show you how to do that in just a second. Okay, I have my plus terminal connected to pin 7 of the rectifier, and pin 7 of the rectifier will have 127 volts on it when it's operating, so I'll put about 125 volts of DC there. And again, none of these tubes will be conducting, so I don't have to worry about damaging the tube. I'll look for voltage on the grid. There should be none, but if there is, it won't hurt the tube because the tube will not be conducting. And I'll also find out if I have roughly the right voltages in several places, so I know there's no shorted capacitors. Alright, at this point the video goes a little bit off the rails. I'm reshooting this. The sharp-eyed amongst you will notice that the radio chassis doesn't look quite the same. Restoration work has moved along considerably. All new caps except for this one waxy, which I have put back in for the purpose of this demonstration. And I've put it in place here as my grid coupling capacitor for my audio output tube so that I can go on with the demonstration. I was in a hurry trying to make the other video. It ended up being 2.5 hours long. I was getting anxious. I was jumping all over the place. I wasn't prepared. I didn't have everything set up properly. We're going to break this one up into 3 or 4 videos or whatever it takes. And we're already about half an hour in, so. Alright. As I said earlier, I used to be a proponent of bringing the setup using the standard isolation transformer and variac until I thought about it a little bit and realized that even using the variac, you're pumping a lot of power into this radio, and the capability or the possibility is there that you're still going to burn up a rectifier, you're still going to do damage to the power output tube. I wanted to eliminate that possibility. I wanted to be able to check the filter capacitors to see if they were even functional, if we could bring the radio up at all just for testing, because a lot of people shotgun the caps. When it doesn't work, when they're done, it's like, did I create the problem or was it there all along? My mindset or my thought process is I'll replace the minimum I need to make it safe for the radio to operate without doing any further damage. Make sure it functions. When I'm sure the radio is functional, I don't have a burned out IF transformer or something odd, open coil, open oscillator coil, and you can check that stuff with an ohm meter, of course. But I wanted a way to check the DC draw from the power supply safely without doing any damage. And turning it on with the variac, when all the tubes are active, they're drawing current. It adds another level of complexity in trying to figure out what's going on. If you just inject direct current into the system without the tubes being active, there's no danger of damaging the tube. I can check my grid voltage here, I can check my filter capacitors to see if they're open or shorted, and I can see very quickly if I have any other shorted capacitors, with the exception of the across the line, which I just automatically cut out of the circuit anyway. I just clip that before I even start on these sets. And I usually shotgun this capacitor in before I turn these sets on. But I'm going to show you why it has to be changed. So I'm going to inject DC. Now, over here I have a Heathkit high voltage power supply. And you're saying, but Vern, I don't have a Heathkit high voltage DC power supply. Don't panic. I have an alternative for that I'm going to show you. I've got some simple schematics drawn up. It's a piece of cake to get around that issue. What I've got is the Heathkit supply, and I'm going to put the DC on, and I'm running 100. I could run 125 volts. This radio is going to have at least, because it's, whoop, there was the camera, because I'm rectifying line voltage, I'm going to have somewhere between 115 and 120 volts DC on the B plus line. That goes into this little box. All this box is a 6-watt incandescent lamp, old nightlight style nightlight lamp, 6-watt incandescent, that at 120 volts won't pass any more than 50 milliamperes. That's a pretty safe level for the radio. It can still give you a hell of a shock, but it's a lot less than you're going to get with the set plugged in or powered up on the variac. I've got a little toggle switch here. When I flip it up to the test position, it's going to dump my 125 volts into these clips through this lamp. And if my filter capacitors, well, let's just go ahead and do it. I'm going to connect that there, and I am going to go down here. Actually, I'm going to go to the one that's coming right out of the rectifier. Here's the filter cap that's coming right out of the rectifier. Now when I flip this switch, you'll see two things happen. You'll see a little kick in the meter as the capacitors charge, and you'll see the light flash. Okay, here we go. Did you see that? That flash, that means the capacitor's charged. They took a charge. You saw the current jump up and fall down. This is telling me a couple things. The filter caps appear to be active. Now let's pretend that's the old filter cap still in there. And nothing's drawing an excessive amount of current right now at 125 volts DC. And remember, the only thing that's active is the DC bus. The tubes are not conducting right now, so there's no danger of hurting anything. That's the reason I go with this test. I can take the filter capacitor test one step further. I happen to have a center off switch, just what I had in the junk box. It's not necessary. You can go directly to discharge, and you'll see that the capacitors, when I go to discharge, it's going to short circuit the filter caps with their charge again through the lamp. It's going to disconnect the power supply and connect the capacitors across the lamp. See that flash again? That's the filter capacitors discharging into here. That tells me the capacitors, the filter caps, are fairly healthy in the set. I could, because I have a center off switch, which isn't necessary, it's just kind of nice to have now that I have it in there. I'm charging the caps, I put it to the center position, and if the caps are extremely leaky, they'll self-discharge down to 0 and nothing flat. But if I wait a few seconds and then flip the switch, you saw the light flash again. Not quite as bright because they're slowly discharging. But if there was no flash after that, you'd say, wow, those caps are really leaking badly. Let's get them changed as soon as possible. But if you can go from there to there and see a flash, the caps are going to be reasonably safe to power the radio up for testing purposes. You can also turn that switch on to the test side and let it cook for half an hour to see if they're going to break down and go short circuit on you. If in half an hour the light is still out, you're not drawing any current, you can feel pretty confident about powering the setup. You know, go have lunch, go have a cup of coffee, come back, the light's still out, the capacitors haven't gone short circuit, and they're at their rated operating voltage. They'll probably be okay for testing the radio. And again, we have our discharge. The second test I'm going to do is I'm going to swing the camera over here a little bit, and I'm going to put my VTVM on the negative bus, and then I'm going to go down. So my VTVM is now connected to the negative to the B- bus, and I'm going to go over here to pin number 2 of my 50C5 and see what my grid looks like. So I'm going to go down here to pin number 2, and did you see the VTVM go up? I am on the 50 volt scale, and there's 35 volts on the grid of that tube. That tells me for sure this capacitor has to go. This coupling capacitor cannot stay. This 50C5 is supposed to operate with 0 grid bias. The 0 grid bias, let me make a quick sketch here. Let's say that's the operating curve of our tube, and at a 0 grid bias, the tube is operating in this region. So as our AC voice or music comes in, it's going to slide up and down within the linear curve of the tube and give us good audio. That's at 0 volts. With 35 volts on it, our operating point's up here somewhere, and that tube has gone into full-blown conduction. Right now, if the tube was active, it would be screaming its heart out, overheating the anode and turning the tube gassy. 50C5s at $40, I don't want them going gassy on me. I want to know that tube is not going to be damaged when I turn the radio on. That is why I automatically shotgun that grid coupling capacitor, because as you can see on the meter, there's almost 35 volts going to that grid. That's voltage leaking through this capacitor. Now I'm going to remove that cap and leave a good cap in its place. Alright, the crappy waxy capacitor is gone. In its place we have a good coupling capacitor, a new coupling capacitor, and I'm going to go back on, turn the test back on, turn the voltage back on. I'm going to go back on that pin, and as you see on the VTVM, absolutely 0 volts on the grid now. That tube is now safe to be turned, or the radio is safe to be turned on. We're not going to damage the tube. That is why I use this DC method. And again, I'm not seeing any current draw here. This is still in the test position. Tells me the rest of the capacitors in there, even though we know they're bad, they are leaking voltage. The radio will be safe to operate. We can test it and then go through and change the rest of our capacitors. If the radio works when we test it the first time, when we change our caps, it should still be working. If not, we know we did something wrong. Okay, as promised, I told you I wasn't, not to panic if you didn't have one of these high voltage power supplies. That is not a problem. I'm going to assume at this point that you do have a Variac dim bulb setup of some sort. If you're working on one of these without an isolation transformer and a Variac and a dim bulb, you're heading for disaster at some point. If you have one of these Heathkit units, you're line isolated. That means you have an isolated AC source. All you have to do, and let's pretend this is our isolated Variac system. All you need to do is put a diode and a capacitor, anything from, I say 20 to 40 here, it could be anything from 10 to 100 microfarads. Nothing critical here. Certainly whatever you have in a junk box. 20 microfarad would be more than enough just to smooth out the DC a little bit. Then we have 120 volts DC out. You're going to control that with your Variac. You turn your Variac up to 120 volts AC. You're going to rectify it, half-wave rectify it, charge up this capacitor. You got 120 volts DC to do the same test that I just did, and it's safely isolated. It's just as safe as using my isolated power supply over there. If you want to get fancy, you can add an optional milliamp meter and a voltmeter. Didn't put these in order. I should have had these in order. The box that's there is nothing but that 6 watt, 120 volt lamp. I got some BNC connectors on the back of this so I can pull the cables off and throw the box in a drawer when I'm not using it and not worry about a tangle, big cable tangle. But the 120 volts DC goes into one side of the switch, comes out the center, goes to the lamp, goes to our device under test. When you flip the switch the other way, the connection's down here, then it short circuits that filter capacitor through the lamp. And it's perfectly safe to do this because the switch, when it switches, it goes from one contact to the other contact. It's going to break one before it makes the other. So there's no danger to the power supply. There's no danger to anything there. If you have a center off switch, terrific. You can use it. That's all this box is. You could incorporate the rectifier and the capacitor into the box if you didn't have that separate DC supply. Very simple, just incorporate it all into the same box. As far as mounting the lamp, they have available on eBay, and I expected to have them here before I did this video. They haven't shown up yet. I think, or was it Amazon? I forget. I'm going to have to look it up. I'll flash up on the screen what I'm talking about, but they have the porcelain thread-in bases for these lamps that look just like the normal porcelain lamp holder or bulb holder that everybody uses for their dim bulb assembly. They look identical, they're just sized for this little tiny lamp. You could set that right on top of your box. You don't have a box to build in? Are you an electrician perhaps? Or do you have access to some electrical supplies? Maybe you do your own house wiring. You could take a gang box, a double gang box. On one side, put an outlet. On the other side, you could install a three-way switch, a three-way light switch. A three-way light switch is nothing but a single pole, double throw switch, just like this one is. Screw this into a night light that plugs into the wall. We all used to have those, well, most of us did when we were kids. The bulb threaded in, this was plugged into the wall, had a little switch for night light. You plug that into one side of the gang box, you got your switch, you got your lamp. Inside the gang box, there's plenty of room to put the diode and the capacitor. You're only limited by your imagination and what you want to do. It's such a simple thing to build. And again, for those who don't have an isolation transformer, if you're really on a shoestring budget, you can pick up a couple of 24-volt control transformers or a couple of 12-volt filament transformers. I think Radio Shack is still available in a few places. You just put 117, 12 to 12, and you get 117 isolated out. Ignore this up here. This was for another video I did. You just put two transformers back to back like that, and you have an isolation transformer. You have your line, your hot coming in, and your neutral. Over here, these two sides are isolated. It's still 117 volts. You can still get nailed on it, but there's no danger of touching this and getting grounded on something and getting hurt. It just is dead simple. One gotcha. Most of your newer radios are going to have a power supply that looks something like this. It may not have this extra line. This is assuming that that they wanted two separate voltages, and they're relying on this voltage drop to supply the other one, 120 DC, 90 DC, whatever. But you may not have this second line. It may directly come out to 120 volts. This is going to be fine for this test. Everything's going to be fine. But if you have something really old, some of those very, very early radios had a power supply that looked something like this. Came out of your rectifier, came out of the rectifier, your first capacitor, you had a pi filter here. They call it a pi filter because it looks like the letter pi. You got your first capacitor, you'd have a filter choke, or in some cases it's the coil on an electrodynamic speaker. The field coil acts as a choke. They use it as a choke. It does serve double purpose. Another capacitor, and then they would have a voltage divider. Some of the very early sets, and sometimes you'll see these big long metal resistors riveted to the back of the chassis. It goes directly across the power supply. They did this for regulation purposes, so it always had a constant load, but it was very wasteful because this resistor dissipates a lot of heat, a lot of energy. But they would go to ground through a resistor, and they have like 250, 90, 45, whatever the taps were on the resistor for their voltages for the different tubes. You don't see this anymore. But if you do have this circuit, if this is what your power supply looks like in your schematic, and you try to do that leak down test that I showed you over here, you're going to get a false indication of high leakage somewhere. So what you'll want to do is break this right here, lift this one lead from the cold end of that resistor and leave this floating, and then you can do your filter choke, and this goes off to your rest of your circuitry, and you can check everything else for leakage before you power the radio up. Just keep that in mind. If you're working on something really old and you see this type of arrangement in the power supply, you're going to have to lift that leg of the resistor before you run this DC test that I just did. Probably never going to see it. Most of the modern radios, everything, if there's any voltage drops, any voltage division, it all takes place along the B+ line. It's a lot more efficient than this system here. Okay, I'm sure this video is getting on to 45 minutes at this point. I'm going to stop. The next video, we will go through troubleshooting. I'm going to do some mock troubleshooting. This radio has nothing wrong with it. It came up just fine. But we're going to show you how to use your either Heathkit signal tracer or ICO signal tracer. They both work the same way. The only real difference is the Heathkit one switches between RF and audio testing right here at the end of the test probe. On the ICO you have 2 test probes and you have to flip a switch on the box to go between RF and audio. So we're going to wrap this up. I don't want this one to run on long. And I can feel my second cup of coffee. I'm getting hyper. We'll see you next time. We'll carry on with the testing. When the next radio arrives, we can go through, we'll go through all of this again. We'll cover this ground again and show you on a different radio than one that's already fixed how to go about this. I'm the Radio Mechanic, and we'll see you in part 3. Thanks for stopping by.